We spend our lives walking around on dry land, but biologically speaking, we are heavily reliant on the ocean within us. The average adult is up to 60% water. Human babies are even wetter. At birth, they are up to 75% water, making them swimmingly similar to fish. This animated graphic breaks down exactly how saturated our internal organs really are. An adult's brain and heart are almost 3/4 water. Our lungs are even more saturated, sitting at 83%. Even seemingly dry human bones are actually 31% water. All of this fluid performs very specific mechanical functions. It acts as a biological shock absorber that cushions and lubricates our joints. It regulates our core temperature, and it actively nourishes our brain and spinal cord. We tend to think of ourselves as solid physical objects, but the reality is much more fluid. We are essentially just walking bodies of water, making it the single most critical structural element to our immediate survival. But this massive internal volume presents a serious biological problem. Despite needing so much water to survive, our bodies are constantly leaking it just by existing. This volume graphic shows the daily deficit. Every single day, we lose between 2 to 3 liters of fluid. It drains away through passive, everyday functions: sweating, urination, bowel movements, and even the simple act of breathing. Because these functions are non-negotiable, the body is forced into a constant biological tightrope walk. It must relentlessly seek out new fluids to compensate for exactly what it's losing. Stepping off this tightrope in either direction, failing to replace the deficit, or heavily overcompensating, disrupts our internal equilibrium and triggers immediate, catastrophic systemic failures. Let's look at the first extreme condition, the drought. The moment internal water levels drop too low, sensory receptors located in the brain's hypothalamus detect the deficit and sound a systemic alarm. The brain responds to this alarm by sending out a chemical messenger. It triggers the release of an antidiuretic hormone directly into the bloodstream. When that hormone reaches the kidneys, it creates aquaporins, specialized channels that open to aggressively absorb available water molecules. Extracting every drop of moisture alters the waste fluid, creating the first symptom of dehydration: highly concentrated dark urine. If the drought continues, the systemic failures cascade. You will experience notable drops in energy and mood, along with a dangerous dip in blood pressure. The cognitive impacts are particularly severe. A dehydrated brain suffers actual impairment, forcing it to work significantly harder just to accomplish the exact same tasks as a normal, hydrated brain. In fact, the lack of water causes a severe physical reaction inside your skull. As moisture is pulled away, the brain actually temporarily shrinks. Thirst is the minor signal of a major physical event, the actual contraction and overexertion of our most vital organs. The opposite end of the spectrum carries its own risks. Consuming too much water in a short amount of time causes overhydration, a dangerous complication often suffered by extreme athletes trying to regulate their temperatures during intense physical exertion. In response to this sudden flood of liquid, the overhydrated brain attempts a biological shutoff. It slows down or completely stops, releasing the antidiuretic hormone into the blood. This creates a chemical crisis. The massive influx of fluid aggressively dilutes the sodium electrolytes spread throughout the body. We can see the microscopic consequence in this animation. As the surrounding electrolytes become diluted, the body's cells are forced to absorb the excess water, causing them to physically swell and balloon outward. The macroscopic results of this internal swelling are severe. The kidneys fail to process the massive volumes of dilute urine, leading to a state of water intoxication. This can cause vomiting, seizures, and in extreme cases, death. While extreme overhydration is rare, the flood proves that water is a powerful solvent. If the delicate internal equilibrium is broken, it is fully capable of destroying the body from the inside out. Fortunately, staying in the safe middle ground between the drought and the flood is manageable. But how exactly do we successfully strike this precarious daily balance? For a long time, conventional wisdom dictated a rigid rule. Everyone must drink exactly 8 glasses of water a day. But that estimate has long since been debunked. This slider visualization illustrates the modern medical consensus. The amount of fluid you actually need shifts dynamically, based entirely on your weight and your environment. Generally, the target ranges from 2 to 3.7 liters, adjusting up or down depending on your gender, activity levels, and the outside temperature. You also don't have to rely entirely on pure water. Fluids are actively replenished by a variety of everyday beverages, even those containing caffeine like coffee and tea. In fact, about 1/5 of our daily water intake comes directly from solid foods. Produce like strawberries, cucumbers, and even broccoli are over 90% water. They supplement your liquid intake while simultaneously providing valuable nutrients. Maintaining your biological homeostasis is rarely achieved by blindly chugging glasses of water. It requires a highly personalized and diverse dietary matrix. Maintaining this daily balance preserves systemic health over the course of decades. By keeping cellular waste disposal efficient and blood viscosity stable, optimal hydration helps lower the probability of stroke. This multi-line graph shows how those same mechanics assist in blood sugar regulation for diabetes management and potentially reduce the risk of specific cancers. Actively managing your daily fluid intake means you are actively preserving the microscopic environment surrounding every single cell in your body. Getting the right amount of liquid is the foundational biological lever that dictates exactly how you feel, how you think, and how you survive day to day.